The Zero Waste Working Group, established by executive order by Governor Lulian Guerrero, is working on a series of initiatives to reduce landfill waste. Currently, over 8,000 tons of biosolids are disposed of annually in the landfill, and this amount is expected to increase. The purpose of this pilot project is to demonstrate that Guam's wastewater solids can be composted with locally available wood chips to produce a beneficial compost product, meeting air testing requirements for use in landscaping, horticulture, and agriculture on Guam.
Let's talk about what you have in front of you real quick, if we could. Of course, I'm Todd Williams, and if you haven't met me, I'm the quiet one. I don't really need a mic, but I can use it if we need to. But this tells you inside the flyer here what is sludge cake, or cake, what is in it, how can we use this material, and how do we address pathogens, microconstituents, PFAS, and all of that. So it talks about that. I'm not going to go through that in detail. But what we have behind me is the demonstration and kind of the life cycle of the demonstration of what we're doing here. You also have a fact sheet, which is a 2-pager. It tells you a little bit more details about the greening roadway infrastructure. If you got questions on that, the pretty blonde lady in the middle there could tell you all about that, Julie. So, but what we did here is we have an aerated static pile. This is just a demo. This is not how we would do something necessarily full scale, but it gives us the information that we need to demonstrate that this is safe, and that this is hygienically safe, and that we've met all of the EPA 503 requirements for Class A exceptional quality biosolids product that is then able to be used without regulation at that point, because you've met all of the standards that are necessary. But we're also doing other tests for our own interests. Should questions come up, if the public has other questions, we want to completely be open with the information. So what you have here, when we built this pile, you saw the video yesterday, right? Mm-hmm. Where we put the base layer down of wood chips. We put an aeration pipe in there. We had inside this container a little fan that's shown here. And we pushed air into that pile and up through the mass of a mixture of sludge and wood chips, which are ground pellets. And we had to blend that. What we want to do is get that to a certain moisture content in the low 40% solid, so about 55 to 60% moisture. And we aerate that for 3 weeks at least. We got on this particular one, we ran it for a month, okay? And that was just because of schedules. It's okay to run it longer. If we do full scale, we want to do it as short as possible so that we minimize the size of a compost facility full scale. So after a month, what you see over here is what is left of the pile. That entire mass was covered by this pile when we set it up. Okay? We monitor temperatures every single day throughout that month-long process to watch how the temperatures came up, to make sure we met pathogen reduction criteria, and to make sure we met vector attraction reduction criteria. So once we achieve that, we want to have enough air to actually lower the temperature a little bit so that we're continuing to stabilize, because more air gives us more stabilization. Now, out here, it's always windy. And so we got nice benefit of that 22 to 25 mile an hour wind all the time, actually providing supplemental aeration. So the amount of aeration that we had to have with this blower was not as much as we would probably need full scale. Plus, we had a smaller pile. Okay? So here's the life cycle of the material. I'll come back to this in a minute. We took the biosolids, we mixed it with the bulking agent, we used a front-end loader, we built the compost pile, and here you see, and you can go look at that temperature probe later if you want to check it out yourself. We put a cover material over the pile so that all of it was insulated. Okay, we put about 12 to 18 inches of finished yard waste compost that LMS had to insulate it, so all of the mixture inside got to that high temperature to meet the federal requirements. Okay, so once we've done that, we have a semi-finished product right now. There's no other regulation that we have to achieve to be able to use that. But we do want to stabilize it further in curing. So what we did was we screened it earlier this week. There's a picture of the screening operation. And then now here we are with a finished product that's going through curing for another month. And the purpose of curing is to continue the stabilization process. What happens when we screen it is we get all of this rehomogenation of the material. You get the wood chips that are broken down with the sludge that's broken down. Now it's biosolids. It all starts to mixing, and guess what? The bugs are like, ooh, new food. You broke up all those surfaces. And so now heats back up, 160 degrees inside that pile. Perfect for stabilizing compost. And, you know, questions came up, what about disease seeds? What about weed seeds? What about plant diseases? What about beetles? What about any of those invasive species? That temperature for that long will kill those things off. So you don't have any of that left. The stuff that you buy at Home Depot in a bag, I don't know if it met those temperatures. Maybe, maybe not. Don't know. You have to read the bag carefully, and it may not even tell you in there. Most of the stuff, like manure, hasn't gone through this process. It's going to stink, it's going to attract vermin, and it's going to piss your neighbors off if you use it. This material here, you put on your lawn, you put on a golf course, we can landscape with it, we can grow all sorts of ornamental crops that are flowering crops, we can grow trees with the material, backfill it. We'll use it perhaps on the Badlands to stabilize that material because that's clay and acid. And we've used the compost in materials in roadways where they couldn't get anything to grow because of that acid condition. Mm. You know, the departments of transportation just gave up and they couldn't get anything to grow. You come in with the compost, blend that in, and now you can all of a sudden get grass to grow because it'll give it the nutrients it needs, it gives the organic content that it needs, and it allows for grass to grow, and it also holds water so that in a hot environment, you think you have hot, you know, in Virginia where I used to live, it'll be, you know, in the high 90s, 100 degrees with 100% humidity, and it'll dry things out pretty quickly as you have here to, you know, to a certain extent. But that will hold the water so we don't have to water as much. Okay? So that's kind of the process. So going back to our schedule of what we did a month of composting. We're going to do a month of curing. So here we did some planning back in last year. We started up in the second week in January where we did the mixing. Here we are today where we screened and restacked in February. We're going to cure for a month. We're going to grab samples to about the third week of March. And we're going to test for metals. We're going to test for pathogens, indicators. We're going to test for PFAS. And we're going to have all that data available to the EPA, thank you, Conchita, to review that, make sure everybody is on board with what that is telling us. And then we will be working, we're waiting for the Department of Agriculture to give us a proposal, working with LMS, working maybe with the University of Guam, who we talked to yesterday, about how we can best use that little bit of product to do some demonstrations so we can document it.
Is that Roland Tidwell?
Yes, Roland was there. Yeah, I talked with him.
Yeah, because Roland deals with all the invasives, so he's perfect for that.
Yeah. He spoke up too, didn't he, about the beetle?
Yes, he did.
So we've got about 30 cubic yards of material there. And remember, we put in about 25 yards of sludge, and we put in about 30 yards of wood chips into this mixture before we built it. So it was filling up this entire area that you see with the base. And we just reused the base. We didn't need to put the fan back on it because at this point we're just using passive aeration, so we're probably drawing air in that little open hole in the end of that pipe because it's hot. It wants to go up, right? The heat wants to go up, so it's sucking, it's drawing air in just to keep it a little bit aerobic. If we put air on it too much, it will just cool it down, and then the microbes can't do their work that we want. So we want it to be in that 140, 160 degree range. It's beautiful. Now what will happen over this month, we'll be monitoring it a few days a week. We're not going to do it every day, but LMS will be checking that every day, every other day type of thing, 3 days a week, and we'll watch the temperatures, and they'll start to come down probably into the low hundreds. And then at the end, we'll sample test, wait for another month when we get that data, and then we'll use the material in some demonstrations.
It's like a 3-month process.
It's really only a 2-month process. We can get finished product in 60 days.
60 days.
Yes.
Where do you get your sludge?
From the 2 wastewater plants is where this came from. The northern treatment plant, great question, and from Hagana. Did I say that right? Probably not. Okay. So, yeah, so that's where 98% of the solids on the island come from those 2 plants.
Yes, this is human waste, that's
Yep.
correct.
And actually, instead, what they do now is they just dump it at the landfill, cover the landfill with it. And there was one time it rained, and the whole Narahan stunk because they didn't.
Yes.
I don't know.
It's not
because
stable.
It got wet, and then so it stunk. And then you know what they did to fix it? They put giant what do you call it? Like
Fans?
no, like aerosol things.
Oh, spray. Yeah,
They
they
put air
spray.
fresheners. I'm not kidding.
Yeah.
There's video of it. They put
Whatever
giant air
leachate generated
fresheners.
goes right into that sewage
Yeah.
treatment plant too.
Question.
So
Comment.
conceptually for us, can you show us what you started with? I mean, we've got a pile here now, but can you kind of walk out there and conceptually show us a little bit about how much you started with?
The base, you get from
We
here?
started with a base of these chips, okay? And we got that aeration pipe that runs the whole length, all the way to the end of that pile. And it has perforations, it has holes in it so that you can run, we had a fan connected, we've taken the fan away because we no longer need it. We had a fan that was blowing air in there and it would go up through the pipe.
But is this the length of it? The length?
This was how big it was.
So from
Yes.
there all the way down to there?
Yes. So that's what we started with. It was about this tall, about 6 feet tall.
1.5 joules.
That's the
One
length.
and a half Julies, yeah, that's right.
The
1
length
meter.
is from there all the way to there.
And so what you see left here, this is actually unscreened compost. You know, when we take it down, this is what it looks like. And this white stuff is called actinomycetes, which are normal, that are fungus that break down the wood and they'll break down the sludge once it gets dry enough. So this is pretty coarse. You wouldn't want to put this on your lawn because there's all chips in it. It kind of looks rough. When you screen it, that's what it looks like.
I'm just curious, you put this in the trucks that haul human waste and then you bring it here?
That's what we did for this demonstration. We just took 2 loads, 2 of those containers.
So you tapped into the wastewater treatment in some area to withdraw the sludge and bring it here?
That's right.
And 2 truckloads?
That's
Because
what
Guam
we
Water Works normally trucks all the way to the landfill. So we took some of their, whatever they trucked, down, they rediverted a few cubic yards here.
That's right. Because this was a small. They do 3 loads a day out of the northern plant and 1 load a day out of Agana. And so we took 2 of those and saved them, you know, $180 a ton and brought it here. Because each one of those loads is about 20 tons. So it was about 40 tons of material is what we put in here. And this is what we have left. Now,
For this thing?
Yeah.
Small,
Yeah, for this small thing. That's what they do every day, I think. No.
here's a probe, 3 foot deep. 3 foot deep. We can stick it in anywhere in this pile. And it'll heat up. It's 164 degrees right now.
Hot pile, wow.
So you said
It's hot stuff.
you said
pile
ornamental
of
trees.
We can grow fruit and vegetable on it just fine. Yeah, I put it on my garden. I put it on my lawn.
Tomatoes are nice.
Yeah, because it provides the nutrients and it also provides micronutrients. Because people call this heavy metals, it's really micronutrients, most of them. And so the plants need that. They need, calcium. They need copper. They need iron. You're going to get that in here.
So on the mulched pallets, the nails and the screws are still in there?
No. So it's a good question. So how do we get the nails out of the pallets, right? We got a guy out there, no. They grind these up in these huge machines, and then they take the ground material and it goes up a conveyor, and there's a magnet on there that pull all the metal out. And that gets thrown, you know, and diverted into a dumpster, and then is probably could be recycled. We haven't gotten there yet with those guys, but that's something, you know, you could do with it. But that ends up being a tramp metal, and now you have clean wood.
I remember over at the Vacation wastewater, they had those cherry tomatoes.
Yeah.
They were using, you know, that human, and their cherry tomatoes was like
Huge,
this.
huge. Yeah, they're huge. I started composting, in case you were wondering.
Yeah.
How did I
No,
get
didn't
into
eat
this?
it, but I said,
How did
wow.
I get into this? I went to school in civil engineering at Virginia Tech. Great university, everybody's heard about it because of all the tragedies that have happened there in the past now. But I was there a long time ago. I went to work running a wastewater plant, similar to what you have here, except it had further treatment. It was a larger plant. And our method of managing the solids in 1981 was to start a compost facility. So we started a compost facility, we read all the books, we went to conferences, we tried to learn about it, and we started composting. We didn't know anything about odor control, we didn't know anything about anything. But we knew that that was a viable option because the USDA had done testing and testing and testing, and the first paper published on it was by my mentor, Dr. Elliot Epstein, and a guy named Parr and a guy named George Wilson wrote this paper in 1976. And you can still find it today online in the Journal of Water Pollution Control that tells about aerated static pile method of composting wastewater sludge. And so we started doing that then, and then I got into the consulting business because at that time there was probably a dozen or 24 plants around North America. And then there was all these ones starting up and people weren't sure how to run it. Well, I was able to help them learn how to do it right so that they wouldn't have odor problems, so that they had good product, to do the most economical way possible. So today there's now over 260 facilities in 44 states, and they're processing over 3 million tons a year of wastewater solids, this method. You guys produce 8,000 tons. So it's a year. Yeah. So it's done from Alaska, Kodiak, Alaska, Fairbanks, Alaska, have compost facilities all the way to Puerto Rico. And it's done in Australia, it's done in France, it's done in Italy. Now, who do you want to have run? The Italians or French? I don't know. I think maybe the Italians, because they're going to use it to make better wine. So this is the process. It's pretty simple. The other thing, when we look at a remote place like Guam on an island, what if something breaks? Do we have any specialized equipment here? We got a little fan. We'll have a whole bunch of them. If one breaks, we just put another fan out there. We can get a fan. We got a temperature probe. We can get those. Look at it's already up 170 in that spot. And it'll probably stay up here for a few days, and then it'll start to taper down. We've got front end loaders. Yeah. So what you see over here, this is the wood chips that we used. This is some of the yard waste compost that they had as cover. So we peeled that off of the pile. And this is the recycled wood chips when we did the screening process right over there. Normally that would be reused into the process until it breaks down and it ends up in the compost. And so now we'll have data. So we do this full scale, we can figure out how big does this need to be, how many tons of pallets do we need to go with that 8,000 tons of sludge, what kind of moisture is all of that stuff. We figure out what we call a materials balance and a process flow and figure all that out. So now we have the data, thanks to the demonstration study, to demonstrate that it's safe. We'll have that, but we also have the data today that we can take this information from this pilot study and we can accurately design a full-scale facility.
Is this a target for EPA to be able to utilize all the sludge at the wastewater treatments? I mean, is that one of our goals, is to be able to utilize the sludge?
Our goal is to get it out of the landfill because that's a waste.
Right. But to give the government options.
Right.
Because at the end of the day, it's up to the government to decide how they wish to proceed with this. We wanted to show that it can be done.
And we there's a possibility to utilize all the sludge at the wastewater treatment for this specific purpose.
And it could fit on this site easy. You know, once we move on.
Well, again, we leave
But
it
we
up
don't
to
know where that is.
Right.
We haven't gotten there yet. But
That's
that
up
just
to the
gives you an
government.
idea. It doesn't take really that much room.
So we're just getting data. That's what it is. We present.
So, question is, do we do this open air like this? No. What happens in September through December? You get a heck of a lot of water. So we want to have it on the roof. We don't necessarily need it enclosed, but off in a roof so that it will keep the rain off. And that is very important for the process, but also so we don't contaminate that water while it's going through the process. We keep it controlled in an environment so we don't have dirty water that we have to haul back to the wastewater plant.
So they're like open bays. I think
Yes.
That's the best way to
So we
describe
could,
it.
we could put bays in with concrete walls, and you put aeration underneath it, and we fill a bay a day, and then we could track that for 21 days, show the compost demonstration temperatures that we need, sample that if we need to, and then we have another bay for the next day.
Very similar. Yeah, they have a smaller scale, and they're dealing, working with food waste and yard waste, halal. So we took a look at their system in Karor. Pretty amazing. Very, very, very rudimentary type bays that you can see where they're moving from one pile to the other. You can see the level of breakdown, if you will. It's beautiful and no smell. But mind you, it wasn't biosolids. But you know, when food rots,
It still has.
oh man, that's an awful smell.
All right.
But I could. There's nothing.
So for the odor, I'm sorry, go ahead.
For the 8,000 tons a year, how big of an operation do you need?
That's
How much manpower?
We're gonna design. We're gonna.
You're getting there?
We're
We're
getting
getting there. We're
We
gonna
haven't
this is
figured
why
that out
let
yet.
us finish, and we will
Right.
have all of those
But you don't
numbers
do all
for the government.
8,000 at one time.
No.
That's true.
No, you're only doing, right now they produce about 80 tons a day.
Okay.
Yeah, 60 to 80 tons a day. So you do the math, and that's how you come up with the 8,000. That's about what they produce. 2 to 3 truckloads from the big plant up north, 1 truckload from the plant in the south, and then these little plants that are out there, they only do water like once a month type of thing, very small. So let's talk about odor, because I haven't talked about that. You smell a little bit here, right? That's because we're doing very low aeration at this point. Full scale, what we did for the demo was we ran blowers to blow up here because we don't have any power out here. We didn't have big, we don't have electricity to be able to run the fans out here, so we brought a generator. We tried to do as much as we could, so that dictated how big the pile we could be, that sort of thing. Full scale, we would do these in bays or something similar, and we would put aeration pipe underneath. And we would draw the air down through the pile, so it would actually suck the air right down through the cover, through the mix, and we would capture that stinky, smelly air, and we would treat it through what I call a biofilter. And that is we run pipe similar to this underneath a bed of wood chips, and we have to give it enough time, and we keep it wet, and the microbes in that wood chips will break down the odors to about 90 to 95% effective. And so what we would do is we would run that way, negative aeration, and that'll capture over 90% of the odors coming off of the pile. It's pretty impressive. We've measured that in huge compost facilities that are doing 800 tons a day. In California and in Virginia, I'm doing 100 tons a day at a facility. We've measured all this stuff in the laboratory so we know with confidence that we can capture odors and we can treat those odors so that we won't cause problems with the neighbors over the other side of the hill.
No methane?
No methane because this is all aerobic. All aerobic. Great question. You go to the landfill, you're going to produce methane, and now what are you going to do? You're going to capture it, or maybe you don't, or you burn it off. It's still going to leak to the atmosphere, and it adds to the CO2. It adds to global, environmental change because you're adding all of this carbon dioxide to the air. Yes.
I have a question. I know it's not biosalts, but I know that leachate is produced in composting processes, and we know this because right after a big storm event, the government had hired a company, and they were chipping away at all the green waste, and we had the piles. But after, I didn't broke down, but boy, you could see that that leachate from the green waste that was puddling. So I'm not noticing anything here. So
we
how
didn't have any. Even with all the rain that we got, and we had a few rain events in January, if you remember, that Mark took pictures from the container looking out at the pile, and that whole area where that pipe was underwater. We had that much water out here. But it didn't bother the process because we had this base layer. So how much water do we generate from this? If we run negative aeration, we're going to get some condensing from that hot gas that's 160 degrees. We'll get some condensing water. We'll capture that in underground storage tank. And now that, pretty stinky, smelly stuff, but it's a small quantity. We can take that and take it to the wastewater plant for treatment. So that's the only water that would really come off the process. By having it under roof, and you basically have no discharge from the compost site. Now, there are other compost things you can look online. They're called windrowing. They do it outside, and they just run a machine through it. What happens to the oxygen in that pile is it goes up when the machine goes by, and then 20 minutes later it goes down to almost zero because there's not enough air for the biology to work. This way, we can control with a blower how much air by speeding the blower up or slowing it down to meet the aeration demands of the biology. Because if biology's changed, it's dynamic. If I start this pile tomorrow, we'll do another mix. Tomorrow, it's going to be 170 to 80 degrees if I don't add air to it. Okay? So that's the process.
The air is kind of like your control.
It really is. It really is. We're controlling temperature, we're keeping it aerobic, and we're making the bugs happy. We're giving them plenty of food. It's like us. You give me some oxygen, something to drink, and something to eat, we're happy. We do the same thing with the bugs. We just got to make sure we give them the right stuff.
Talk about the drinks.
The drinks?
Water.
The water?
Talk about the drinks that they needed,
Yeah, so for this demo, because the water, the sludge is dewatered, they did such a good job at Guam Water Authority taking the water out. We had to actually add water a couple of times because we started drying it out. And so we actually had the fire department come down here and throw a bunch of water on it. We added about 650 gallons on this little pile one day, and we had to do it again just to keep the bugs happy because we started a little drier than we had wanted to because they dewatered so well. So now we know that, so we go full scale. We would develop recipes and say, okay, if it's that dry, we'll add the water right in the front.
And that was with the rain.
That was with the rain.
Even when it was raining, they still had to add water.
Yeah.
What are your tanks?
This is where we're measuring temperature every day for the next month, or every other day. He's not doing it every day now. There's no regulatory requirement. It's more for me when I'm talking to him on the phone from Michigan. Hey, what's going on with the pile today? And if he has any questions, concerns, we talk through that and we make adjustments.
So when it's ready to give away, are you conveying it or people come with their own buckets?
We haven't got there yet. And it's not going to be given away. And it's never going to be given away. This is valuable product we sell.
Oh, you're gonna
Never
sell
going to give it away.
You're gonna
Too
sell it.
valuable.
He's already loading up his truck.
Too valuable.
So what it is, that's why once this is cured, once it's done and the tests come out, we feel very confident that the test results are going to be very favorable. Then we work with, that's why we've been in discussions with Chelsea's group, Department of Agriculture, because then the next step is how well does this work with ornamentals? Now, Chelsea also wants to do on the side and get data on certain produce. Yeah, but so that's the next demonstration project is how well this works with agriculture type things. Okay, with Department of Ag plants, and then the other one is the one that's interested is the University of Guam, Roland Quiricua, because of the rhino beetle.
Right.
So people want pieces of this because they want to run their own demonstration project. So we'll work that out with them. So this is not expected to stick around.
This 30 yards will be gone. As a matter of fact, I've already talked to Chelsea a number of times. It's like, how are you going to split that up? Because you don't have that much here. I want good data, Chelsea. So you got to tell us how you're going to use that 30 yards. Well, I'm going to use 5 yards for this. I'm going to use 5 yards for that. I'm going to use 15 yards over here. And it's, whoa, wait a minute. That's 25. What are you using too much? So we're going to have that discussion because what we want to demonstrate is what's normally done on Guam to grow different trees, vegetables, whatever. You know, we're not probably going to focus so much on vegetables. We're going to focus on trees, the landscaping. What can we do on the badlands? You know, so we're going to look at those types of things on this demo. Okay?
So this is a 6-month pilot project.
Yes, roughly.
Then you got your testing.
Yes.
When will you do this again?
Don't know.
Well, once we get the details, then we go into the design and then we present that to the government. We present it to BSP because a lot of this is planning, and we leave it to BSP to make that decision.
So the testing, from the trees now, right? You're testing that right now, or
At least that's what we're
Getting
waiting
into.
for is agriculture to give us the plants. What plants? So then we do the demonstration on certain plants, if you will. We work. Our initial goal is not to work on produce, right? We're looking at landscaping type application, right? For the most part. But ag wants to try to expand it a little further. I said, but as long as we get data, because it's all about data for us.
That's right.
yeah, because it's important. I think this island is really struggling with coconuts now. Because of the rhino beetle. I mean, I had like 6 and I had 1.
So we agree.
So,
But you'll find that everything is methodical and it is science based. We're not doing any guesswork. We will know everything, so that way when the questions are asked, when we go into the design phase, we have that information for the government of Guam. And I know, Julie, I know you met with Guam Waterworks, you met with some DPW, and they've expressed an interest in using some of this.
Yes. One of the things I wanted to mention with the biosolids compost is the composting project makes a lot of the macronutrients, which Todd and these guys are in the process of measuring, available. Those come from, in addition to the other materials that are in the biosolids, a lot of that is elements that are in the earth, and a lot of our plants, landscaping plants, horticultural plants, and vegetables need those essential minerals and nutrients, right? So they preferentially uptake those, and they just go. Some certain plants will just like take to it. I like bananas. Bananas be like this, and they'll grow really, really, really fast. And that's part of the DOA demonstration work. But it's amazing. We were talking about on the mainland, certain nurseries will drive 100 miles to get this, specific biosolid compost because of its essential nutrient composition from that particular plant.
Right. They'll pay.
It's pretty exciting.
They'll pay $15 a yard for part of the mainland, and they'll sell it for $45
Yeah.
at their nursery yard.
Yeah.
In bulk.
And we are, when you dig, when you are repairing roadways or when you're putting new roadways in, you're creating something to drive on, but you're disturbing land when you create something to drive on. And as a result, you have the berms on the side of the road that are graded for stormwater runoff that are disturbed, that have to have erosion control put on them until the vegetation is established. And this is great revegetation material. I mean, it makes the vegetation grow super fast. And so we've been talking to DPW and GWA about that.
The songs to use that. I mean, there's a lot of uses, but again, we need data. That's
We
really
got
what
it, we
comes.
got it,
Data.
we got it.
Everybody's excited, but I have to bring everybody back. We need the data first and
We're like,
do the
let's
design.
do this now.
Yeah.
No, we need data.
Okay, so how we doing on time? You want to go back there because I got a little gift for you since you showed up.
Did you want to show what those are? So let's.
No, we just pointed. So here is the wood chips that we can reuse in the compost process the next time around.
So
And that'll continue to break down. We'll probably get 2 or 3 uses out of this.
This is all from
Power Authority
This is
trims
pallets.
trees like every.
Yeah, that's
and then
another
they chip
potential.
'em, so you
Yeah.
could actually use those wood chips.
You absolutely could. This was easy because there's so much of it around. So we went after this. The issue with chipping of brush is you have to make sure it's clean. I don't want that trash. I don't want trash on the side of the road in my compost.
They like to put things in
Yeah.
plastic bags.
Yeah.
Pure pallet.
This is pallets, all broken down now, right? So normally we would reuse that, and then we don't have to have as much new. So we just have a little bit of new each time, and we reuse that.
Today, on behalf of the Zero Waste Working Group and the chairman, the first gentleman, Jeff Cook, thank you very much for your support to the Guam legislature. Thank you for your support. I mean, the thing about when people ask, I think it was Patty Arroyo. Patty Arroyo asked this question in her show. She goes, well, whose responsibility is this? And the short answer is the community.
Everybody.
It's everybody.
Yep.
And then there was another question. This is Ty's show, and he says, "Well, what is zero waste?" So I want to make sure we answer that too. So zero waste is a goal. Zero waste is a change, and it's a change in terms of mindset, and stop looking at waste as a waste, but a potential resource. Mm-hmm. And if we start thinking of that as a resource and not a secondary product, but maybe even a primary product, we can get away from some of the concerns. We understand what the concerns will be with this. Because the first thing you tell people is that, well, you know, where did it come from? You say the wastewater treatment plant. You know, people are going to be concerned. We understand that, okay? But if we go out and do our outreach and education, and we show them that this is what it's being used for, we give them data and showing that it is safe, then I think we can help in terms of changing that mindset. And on that, thank you, Dunkel Nasizuus Maasi. Thank you to BSP for their support. Yeah. Thank you to the Port Authority of Guam.
Yes.
Thank you to LMS.
This is a great idea. This is the type of things we need to start looking at. First of all, to reduce the waste stream into the landfill. We just recently borrowed more money to expand the landfill and create another landfill cell. So anything that we can do to reduce the waste stream into the landfill, I think, is good. But in addition to that, we're not just reducing the waste stream into the landfill, we're creating a new use for the waste. And I think in terms of agriculture, I think there's many possibilities that we are excited to take a look at and figure out how we can use it for agriculture. I'm thinking it can be used for farming. It can be used to make soil better in areas that have bad lands and bad soil, and maybe convert those into farmlands. It can be used for landscaping, ornamental plants. But of course, we want to see all of the data and make sure that it's viable. But so far, it looks very promising. And I think definitely right now we spend a lot of money. Of course, farmers will attest this, and anyone planting plants or even gardens in their homes, they buy soil from off island. We buy potting soil, right? We buy it at the store. This could potentially replace that. So I think there's many possibilities, many good implications for this type of a project.
I believe that this is something very positive for our community. This is an alternative that we can use, a resource that we can use within our community that promotes farming, that also deals with a lot of waste that is going in our landfill, most specifically human waste, and we're repurposing it for the purpose of farming. And this will, I feel, also increase awareness to see how we can move and evolve into a zero waste community, especially within our small island where we're very limited with the amount of land that we have. But in the long run, a very positive effect for all of us to see our government agencies working together, BSP, EPA, Guam Waterworks. This is something positive that we can move forward to reducing human waste being put in the landfill, but rather repurposing it for the sake of bringing compost and putting it in our farms, and no longer having to bring in compost and soil materials. We can be sustainable within our own island.